transportation environments. This is J.C. de la Garza. This effort is 3 years and $3 million. The technical point of contact in this effort is Mike Bellone. Next chart, please. DOE is pursuing the technical basis on fuel integrity issues associated with the long-term storage and transportation of commercial light water reactor spent nuclear fuel. To date, the focus has been on the 4 main cladding types for PWR fuel, the zircaloys, Zerlo, and M5. Emphasis has been on development of experimental data on cladding material properties and behavior. This emphasis captures a majority of the fuel used in the U.S. fleet, but has not addressed all of the fuel of interest. Work remains on BWR fuel cladding, integrated fuel burnable absorber, PWR fuel, or newer cladding alloys. Next chart, please. Computer modeling and simulation needs to be developed on the performance of commercial spent nuclear fuel under long-term storage and transportation conditions. This modeling needs to assess hydride behavior in spent fuel cladding through drying during the pool-to-dry storage transfer operations, looking at hydride reorientation, pellet-to-clad interaction, and pellet-to-pellet connectivity benefits, and resistance to beam loadings to individual fuel rods and assemblies in the as-radiated and dry condition. Next chart, please. Chart 4. What is needed is a benchmarked modeling capability to assess spent nuclear fuel performance in the long-term S&T environments for other fuel cladding types, along with separate effects tests for benchmarking specific models. The tasking is to evaluate the existing database, particularly for hydrogen dissolution / precipitation, and perform separate effects tests. Benchmark code to existing data, and use the benchmarked code to assess spent nuclear fuel performance behavior to BWR, IFBA, and other cladding types in the U.S. fleet. Chart 5, please. Work to be performed: hydrogen dissolution / precipitation data inconsistency resolution. Effects of cold work on hydrogen precipitation under stress. Conduct separate test effects on non-irradiated pre-hydrited samples. Let me repeat that. Non-irradiated pre-hydrited samples. Effects of hydrogen content. Conduct separate effects tests on non-irradiated pre-hydrited samples to determine the effects of hydrogen content. Again, that's on non-irradiated pre-hydrited samples to determine the effects of hydrogen content. Slide 6, please. Task to be performed. Develop a detailed plan for conducting the work. Conduct the study to develop the hydrogen dissolution precipitation data needed. Study the effects of cold work on hydrogen precipitation under stress. Conduct a separate effects study on the effects of hydrogen on cladding behavior. Any additional testing proposed should be addressed in this task. Develop models supporting data developed for hydride formation and associated long-term effects. Chart 7, please. Deliverables consist of a detailed study plan, topical reports, and progress reports, quarterly reports, annual progress reports, and of course a final report. And we stress that the final report be submitted 3 months prior to completion of the project in draft form so that we can provide comments that to be incorporated in the final report. We'll be happy to take questions at this time. I am going to refer questions to our technical expert, Mr. Prasad Nair, to whom I am now passing the phone.
Yeah, this is Prasad Nair. Please go ahead with any questions you may have.
Prasad, we only have one question so far. On the task list that JC referred to, do PIs have to complete all of those tasks or a subset of those tasks in the proposal?
It's expected that this is a comprehensive program. We're because it's integrated in many respects. We expect all of those tasks to be performed. So when they put a team together, we expect that it's all covered in some form or the other. Because there's also work going on in this program, in our program, we address many other things. This IRP was written mostly to facilitate things that we will see as complementary to what we already have. So the short answer is yes, all the tasks need to be addressed.
It looks like you are not wanting to examine the effect of irradiation at this stage. Is that correct?
Yeah, that is true, because what we are trying to also do is get more of the unirradiated testing done by the universities. We do have programs internally right now working with irradiated materials. So part of our expectation is by having less irradiated material need to be tested in the university circumstances, more folks can participate in this program.
How can we find out more about the ongoing work from which the IRP is based on?
One way is for individual folks to contact Mike Ballone, who's the TO technical point of contact. There is also in the literature part of the UFD, which is the used fuel disposition campaign, and there are published reports out there. And if you look in the web pages, you might find that. Short of that, if there's a specific request for something, we send it to JC, or JC would probably be able to coordinate that.
Does this IRP work scope involve any experimental work?
Yes, it will involve experimental work, because some of those things, for instance, if we take the cladding, drying out cladding, and some of the concerns for our long-term effects is hydride formation. So there is variations in the initial conditions of some of these cladding materials, particularly when you look at rolling initial conditions with how it's been processed. So initial process factors do have hydride formation variations. So we'd like to know what goes on with that, and it will need experimental work to address that.
I don't see any mention of uncertainty quantification. Do you expect any UQ on the simulations?
Yeah, we would expect that as part of most of these piece of work will have. In modeling, they're straight models of processes, but then when we try to integrate how well we know some of these things, yes, the uncertainty quantification would be an added benefit. And so we encourage folks to do that.